welcome back. Today we're going to be making another spatial map. We're going to be making what's known as a dot density map, where we take a map that has spatial information on it, and then we take data that has precise locations, and then we put a marker at each one of those locations. So before we did choroplast, where basically we shade entire regions of a map, and now we're going to put things in precise locations. We're going to put it on a map of the world, and so we need longitude and latitude basically to control where these are. Also in this video, we're going to show two new things: a new way to import and handle data, and a new way to construct a Plotly visualization that handles a lot of sort of the busy work that we've been doing behind the scenes. Just so that you know that both of these exist. They're probably the more popular way that people do things online, and so it's nice for you to see this sort of at the end of this first module of the course. Again, we took the longer approach before because we were trying to help you see how these data visualizations are put together and understand what you can and can't control. And now that we've done that several times, let's see some other ways of constructing this. So of course, the first thing that we need is data. So I'm going to draw in this housing CSV. And inside of this housing vs CSV, you see I have longitude, latitude. We have some information about houses. This is actually all for information about houses in California, as we'll see in a moment. And so we have the housing age, the total rooms of these houses, total bedrooms, and we can just there's a fair amount of information about all of these houses, and you can see that there's 826 pages of this information. So there's quite a bit here, and we'll talk about how to handle that as well. So we want import Marimo. Why not? Normally we would be importing Plotly subplots so that we can make subplots, but we're going to use something else instead this time. We're going to use import Plotly.express as px. And so Plotly Express, again, as it maybe sounds, is a way to quickly build up Plotly figures. Again, it's going to hide a lot of the details of what's going on. And so we didn't show this early on, but yeah, we're going to use it here. And then we're also going to have a new way of importing data using pandas. So pandas is a sort of data frame, it's called, oriented program. And really what's happening behind the scenes in pandas is that you're taking these NumPy arrays that we've been working with and organizing them into a group, almost like a worksheet. And then this is called a data frame. All right, so let's import all three of these things, and then we'll start working with the data. So to import things in pandas, we've called this PD. So it's pd.read CSV. We have a CSV file, and we say housing.csv. And so that's it. It basically already understands by this function, read CSV, that how to handle and parse this CSV. And so that's all the information we need. It's also going to spit out sort of a table. Okay, it looks a lot like this table here. And maybe behind the scenes in Marimo, when it's showing you this, it's actually just running pandas. I don't know, I haven't looked into it. But yeah, here it is. You have longitude, it's telling you the type of number it is. It's telling you the min and max of these values. And so, yeah, there's a lot of summary information here that immediately comes out when you use pandas. Quite nice, but there are some drawbacks, and there are times you're going to want to use NumPy as well. Okay, now what we want to do is we want to try to make a map that has points of data on it, a lot like a scatter plot. And so we need a map that looks like a scatter plot. And so we'll say fig px, we're calling Plotly Express now, and we're going to use a function to construct a scatter map. Okay, so well named. The way Plotly Express works is it kind of expects a data frame, which is also why we're introducing the idea of this data frame. And so let's give this a name. So how about housing? Housing info? I don't know. Okay, housing info. And so now when I run this, what we saw before was assigned to housing info. If you really like seeing that output, you can just say housing info again, and there's the output. Okay. So it expects there to be a data frame to work from. You'll notice that I didn't, normally when we've been using functions up till now, a lot of times we said something equals this. And those are what people call like keyword arguments. There's a key and it equals something. In this case, this is what we call a positional argument. And it knows what we're giving it just by the position in the function call. So this needs to be the first thing. And Plotly Express says, okay, the first thing is going to be this data frame. Okay. In order to assign where the points are on the map, we need to specify a latitude. And we call this latitude equals latitude. What's happening is that by supplying the data frame, so in this line, we supply the data frame Plotly Express will use to generate data visualization. It basically knows this is what we're working with. And so when I'm giving it these strings are the names of the columns. So I'm saying for the latitude, look for the column that's titled latitude. For the longitude, look for the column that's titled longitude. And then let's see, what else could we do? We could say, well, maybe that's all we need right now. Let's just say that's the only thing we want to do is construct this plot. I'll hit return. And I guess we need to show the figure. And here it is. I'm going to zoom out. It's just a regular old map. And what do you know? What we have now is a map of the world where all the data is plotted on the longitude and latitude. And it just so happens that all those values were inside California. And so we've made our map. Now, we could change a lot about this, and we're just about to, in fact. But yeah, this is the basics. Okay, what could we change? Well, if I run this again, I'll just run it again real quick. You'll notice that the output, when we started, well, I guess I'd have to restart the whole kernel. Let's do it. That's fine. Doesn't take very long. The sort of default that we had here was kind of a useless level of zoom. So we'll rerun this, and yeah, we're like super zoomed in. Here's Bakersfield. Okay, I can use this sort of like, okay. Bakersfield is a town, if you don't know, it's sort of in the middle of the Central Valley in California. So is it likely that that's really the thing we want to show? Probably not. And so instead, what we can do is we can, and I should say, put it down below like we're used to. Instead, we can specify how zoomed in we are and where we're centered to start. So let's say center is going to be in terms of latitude and longitude. I looked these up before what would work, but of course you could interrogate these data points and understand like where you would like it to be centered. All right, so all right, now we are centering here, and the zoom level is kind of weird. Again, we'd like to maybe pull out a little bit more. And so we can do that by saying zoom. And again, I played around with this. You can play around with what you want. But zoom 4.5 for me worked pretty well. All right. You can see that it's not maybe perfectly centered up and down. And so we could move the longitude up a little bit and see what happens. So probably like 37.5 is about right, actually, to get all of California centered on here. Okay. What else could we do? Well, I guess one thing is, yeah, we can see all these points, okay? But we can't really see them because they overlap with one another. And so we would maybe want to control what these data representations, what we know in Plotly are called markers, look like. And we would do that by updating the behavior of the markers in this plot. And so let's see what happens. Let's just try it. Marker equals dictionary and size. Let's make them real small and see what it looks like. Equals 1. Here it says scatter map got an unexpected keyword marker. But that's what we've used before in order to adjust this. Now, the problem is that we're not using the same approach. We're not using this sort of like Plotly, make a subplot, add things into it. We're using the Plotly Express. And so one reason that we spend so much time thinking about this other version is that we know how to go in and modify different aspects of it. We know that really what we have created when we go back and see this when it runs is a figure object that has a trace inside of it, and then we adjust things about that trace or the layout or the axes. And so we're trying to adjust things in the trace. So what we really want to do is say fig update trace, and then we can take this information about the marker that we want to apply, and we can put it inside of the trace. When I do that, update traces, sorry, we will have much smaller markers, right? So let's go back maybe 5. Is that what we had to start? Possibly. Maybe they were even a little bit bigger than that. So you could adjust this and try to figure out if there's like a size at which you feel like you can see a reasonable amount of data, but still in areas that are heavily populated, this is going to be basically just a solid block of color. Something that we have seen that we have control over before, I think, is the opacity. So we can say, let's make this like 33% opaque. And now you'll see that there are regions where like it's lighter and darker based off of how populated it is. We could try to push this down even more if we wanted. We start to lose some of this information, so maybe we bring it back to be large. And you can, play around with what's the balance between the size and the opacity that's showing you the information that you want to see. I mean, I don't really know that I have a strong opinion on this, but just something worth playing around with. All right, what else might we do? Well, we have a marker, and all it's really doing right now is showing us where each value is. And we saw when I zoomed in before, like a lot, that these are all grids. And so really we just have information about houses in particular like districts of California, not like individual houses, but that's okay. We could try to get more information. Like this only shows us where houses are. Maybe we would care about where houses are most expensive. And one way to show that would be to make a bar chart where we could see that, or like a histogram where we could see the distribution of prices. But we lose spatial information. We're going to gain accuracy in how we show those values, but we're going to lose spatial information. We could attempt to show that here in the choropleth that we were working with before. We saw that we can tie color to another axis. And so we can do that here as well. We could basically say, hey, while you're doing this, why don't we color them? And we'll say color them by, if we wanted to know something about the value, median house value. All right, and then if I hit return, we'll get these points not only placed where they are and with the opacity and size that I wanted, but tied back to this color scale here. All right. And we could do other things. I mean, here you can see like the most expensive houses are kind of along the coast. It's what you might expect. There's some expensive houses here. There's kind of a few reasons for this. You're close to the capital, close to Tahoe. So both of those might be reasons why you have more expensive houses there. But we could also wonder like, what about total rooms? right? Like, is there a dependence on the size of the house? And does that sort of match the same that we have here? And so instead of median house value, we could do total rooms and see the spatial distribution there. Man, apologize that I'm such a bad typer today. All right. And here I don't see as big of a pattern as we did before. And so this is the advantage of this scatter plot, and then trying to use this sort of like Z-scale or color scale to show these patterns. I can immediately see, yeah, there doesn't appear to be anything at this sort of scale that I can see a pattern about the size of houses. Whereas before, yeah, I could. Okay, so let's just go back to median. Median house price, I think it was median, yeah, house value, there we go. And then we have this plot. Okay, now what else might we want to do? We had seen before that we can control things like the tick marks, and the way we would do that is with the color axes. So fig.update color axes. Before we had to assign the color axis to color axis. If you go back and look at the Choropleth, Plotly Express does this right away. This is the color bar that we want to adjust. Dictionary, and then we would say ticks equals outside if we wanted to have tick marks on that scale bar. So we have all those sorts of tricks still. And I guess that gets us to the point that we can make a reasonable looking map. You could try to control things with its layout again. You could dig into the options associated with this to see if there's different representations of the map that you might be interested in, where you could control, like, again, the coloring of the water, how these borders on the states are drawn, and so forth. But by and large, this is how you build up a scatter map. And the last thing that I want to talk about in the next video for this whole part of the course is basically adjusting this color scale and how to choose that. I'll see you in the next video.